Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 17 of 2014 JEE Advanced Physics Paper 1. So let us start with question number 17. Hello students, question number 17. Consider an elliptically shaped rail PQ. This is a rail which is elliptical, this shape is elliptical, and in the vertical plane, this is in the vertical plane, that means this is kept like this. This is how it is kept in this plane, so it is kept like that. So it is a vertical plane. So in the plane of the paper, you have to keep this rail like that. The vertical plane with OP 3 meter. This distance is 3 meter and OQ is 4 meter. So this distance is 4 meter. A block of mass 1 kg is pulled along. This is a block of mass 1 kilogram is pulled along the rail PQ. So it is pulled from here P to finally Q with a force of 18 Newton. So the force acting here is 18 Newton, which is always parallel to the line PQ. So PQ is a line which is directly joined from P to Q. There is a rail like this, and this distance is PQ. The direct line joining the point P and Q is the displacement. You can say this is a displacement PQ of this block. It's starting from here, goes to Q. So this PQ direct line is called the displacement, and the force acts always along the displacement during its motion from P to Q, and that force is constant, which is 18 Newton. 18 Newton is the force which is always in the direction of PQ. So if PQ is like that, so I'll draw the diagram. This is P, this is Q, and the force is always in this direction. The force is always in this direction of PQ. This is the displacement direction, and the force is also in the same direction. And the displacement, because this is 3 meter, this is 4 meter, so displacement, this one will be 5 meter. Assuming no frictional losses, the kinetic energy of block when it reaches Q. So from here, this block is moved towards Q. When it reaches Q, the kinetic energy of the block is given by 10 N joule. The value of N you have to find. Acceleration due to gravity 10 meter per second square. So the rail is elliptical in nature, something like that, something like this. If I see that the block is moving along this, not along this straight line. The equivalent diagram is the block is actually moving along this diagram, this line. Whether the block is moving along this path or directly from here to here, this means the same thing, because in finding the work done, we have to find the displacement in the direction of force or force in the direction of displacement. So to find that, we know work energy theorem. We have to use work energy theorem. It said that the work done by total work done, the total work done by all forces is equal to change in kinetic energy. So in this situation of P to Q, the block is here being pulled along this line, which is parallel to this always. This distance is 3, this distance is 4, this distance is 5 by Pythagoras theorem, and this is 90 degree given, so this is 5. So you have to find the force which is 18 in the direction of displacement. Displacement is 5. So total work done, there are two forces involved. One is you can write the total number of forces. If I draw the free body diagram of this block, then it is acted upon by gravity, which is vertical downward, that is mg. The force which is externally applied, that is external force, that is equal to 18 Newton, and must be normal direction. So there are 3 forces involved. So if I find the work done by external force plus work done by gravitational force plus work done due to normal reaction, this is the total work done. That must be equal to the change in kinetic energy, that is final kinetic energy minus initial kinetic energy. As the block starts its motion from rest, its initial kinetic energy is 0. So this equation will become work done due to external force plus work done due to gravity plus work done due to normal reaction equals to final kinetic energy. So if that is the case, let us put those values in the equation and see what we'll get. Work done by external force. In case of the path followed by the particle is elliptical, but then force is in this direction, force is always in this direction, that is 18 Newton. Whether the body is here or the here, the force is always like that. If the body is here, then also the force is also like that. The force is always parallel to this line. So when it is here, the force is like that. So when whichever is the position of the, so when it is here, the force is like that. The force is always parallel to this line. So to find the work done by external force, we write the force dot S. This is how you find the work done. This is dot product of force that is applied and the displacement. What is the work done by this? So this force in the direction of displacement. Finally, this is the displacement, and the component of the force, if the force is acting somewhere else, we will take the component, but here in this case the force itself in the direction of force. Suppose that in this case this is the displacement direction, suppose 5 meter, this is 5 meter, but suppose that the force is acting at an angle of say 30 degree with the displacement direction. Suppose this is 30 degree, then this you have to take f cos 30 is the component, f cos 30. Suppose it is 18, then it is 18 cos of 30. So this way you have to take, but here the force that is 18 is always in the direction of displacement, so you don't have to take the component. Therefore this force Fs, this force is F and S, and this is cos of 0 because it is always parallel. So F is 18, S is 5, and cos 0 is 1, so it is 90 joule. This is the work done by external force. Next way to find the work done by gravitational force. So gravitational force, as the body is moving, this is the vertical plane and the body is moving from this to that, you have to actually find the height responsible, because in a gravitational field, if the path is like that, then we have to see the vertical displacement of the block. What is the vertical displacement? When the body moves from here to here, so this is the vertical height. So this is the vertical height, so this is the displacement. So In case of gravity, when the body is moving from here to here, in the gravity, the height that is moved is the distance that is moved in vertical direction is this. This is the case. This was in this case. So then, if it is coming to this point, then this is the vertical height that is raised. So this vertical height is the displacement for this point is O. Then OQ is the displacement in this direction, because the curve was like that. This was the situation from here to here. So this is the vertical height, and the vertical height is 4 meter. So work done, because gravitational force is conservative force, the work done is independent of the path followed. It depends on the vertical height, initial and final. So work done by gravitational force is again we write F dot S. This is mg s and cos of 180 degree, because gravitational force will be acting downward and the body is moving upward, initial point and final point. So the vertical height here is 4 meter. As you can see, the vertical height is 4 meter. mg is acting downward and this displacement s is in the upward direction, so there is angle of 180 degree, so negative, so minus mgs here. This is the s here, or I'll write h here, vertical height. So this is minus 1. 1 is the mass of the object, acceleration due to gravity is 10 and height is 4, so it is minus 40 joule. Next is to find the work done by normal direction. So during displacement, the block when it is moving slightly, displacement ds in this direction along the rail, the normal direction is either upward or downward, depending on whether the block is pressing the rail or the rail is pressing the block. Suppose that normal direction is this side, then the normal direction and this displacement is always 90 degree. If this is the displacement at any instant, then when at each and every point, this is the normal direction and this will be the displacement. When it is here, this is the normal direction and this is the displacement. So the small displacement and this normal direction force, they are always 90 degree to each other. So each such work done will contribute to 0. So net work done by normal direction is 0, because n vector and s vector makes an angle of 90 degree. Cos 90 is 0, so there is no work done due to normal direction. So we have 3 types of work done. One is positive, one negative, another is 0. So the total work done is 90 due to the applied force, minus 40 due to gravitational force which takes the energy, and no work done by normal direction. So the net work done is 50 joule. And using work energy theorem, we have seen that the total work done that we are doing is equal to the change in kinetic energy. So the change in kinetic energy here, 50 equals to the final kinetic energy minus initial kinetic energy. The initial kinetic energy was 0 because the block starts from rest, and the final kinetic energy we are supposed to find. So this is the case. From here you will get kf equals to 50. But in the question is given that the kinetic energy of the is given that the kinetic energy when it reaches q is 10n. So this 50 joule is equal to 10n. If I solve that, 10n is 50, so n becomes 5. This is the answer to this question. So the answer to this question is, the value of n will be 5. This is the answer. This is the answer to this question. Okay, thank you.